Hi everyone, welcome back to the channel, and today we will be solving another problem from our heap section. Let me show you the problem statement. Wait. So this is the question, find median in a stream. So this question has been asked in a lot of interviews and it's a very good question actually. Let me just start with it and check if I'm live. Okay. I think we are. Okay. So what does the question say? This question has been asked in a lot of places with some different kinds of functions. They might ask you, for example, in GFG, they are asking you three functions that you have to complete. One is insert, other one is balance heap, third one is get median. Let me tell you what actually this is. So the final output of this question should be the median. Okay. So given an input stream of n integers like this, your task is to insert these numbers into a new stream and find the median of the stream formed by each insertion of x to the new stream. So for example, every time you consider each number of this array as a new number that you are inserting to one particular group of numbers. Okay, so at that instant when you are adding the new number, what will be the median? So first of all, you need to know what is a median. So median, in median you can say that if there are odd numbers, right, the count of numbers that are inserted is odd, then in the sorted order the middle number will be your median, and if the count of numbers is even, then you take the average of the middle two values, and mind it should be in the sorted order, right? Now let me tell you 5 15 1 3 what. Okay, so this is your 5 15 1 3. So for every instance when you are adding a new number, you have to, your function, your code should be in such a way that it is able to tell the median at that instant, not just for this complete array. For this complete array, if I talk about, then the median would be, what would be the sorted order? 1 5 1 3 5 15, right? And since there are even numbers here, it will be 5 plus 3 8 divided by 2 4. But this is for this particular instance, and let's check one by one for every instance. Right now, for in the pool, let's say I have a pool of stream of integers in which first I have 5. So when only there is only one number, your median is going to be 5. This is going to be your output, correct? Now next addition to this pool is 15. So now you have 5 and 15. These are even numbers. Okay, what is the average of these two? So that will be 10, 20 by 2, correct? Next up we have 1. So when I inserted 1, I will choose the middle element in the sorted form. So 1 5 15. So from this I will have 5 as my median, and when I inserted 3, I will have 4 as my median, correct? So you will see that 5 10 5 4, that's what they have shown you here as output, right? So this thing is clear. Now another thing is, how are we going to do this question? Okay, so first up, if we go by the conventional approach, that is, every time I am inserting a new number, I have to place it in the right position of the sorted order, right? So you can use insertion sort, probably, up to you. For example, if I go by insertion sort, you'll every time check its position, okay, insert its new position, right? Or even if you don't go by insertion sort, maybe you just check one by one for every integer. At max, when you are inserting, 5 is there, 15 you want to insert, although right now it's in its correct position. So for example, I insert 1, now I want 1 in its correct position. So you'll compare with rest of the numbers that you have. It will be compared with 15, so 1 it will be swapped, 15 will come here. Then you compare 1 with 5, it will be swapped and 5 will come here. Then the remainings, are they in their correct position? So all in all, it will take you big of n square of time complexity, right? So can we do something to improve this time complexity? That's where we come. So before I move with towards this approach, one way that I'll suggest you to try on your own is binary search. The hint I've already given you. Try it out yourself, how binary search, actually it's pretty straightforward once you know how binary search works. Okay, try doing it with that also. Now let's discuss how heaps are going to help us improve the time complexity. Okay, so wait. The whole idea of this question is that if somehow whenever at any instant I am inserting a new element, right, I just need to know what all numbers I have that are less than that current number x and all the numbers that are greater than x. So somehow if I have something stream of integers that is keeping track of numbers that is less than x, maybe here, and giving me a track of numbers which are greater than x in the other pool, then maybe I can make some decision. How is that decision going to be made? Let me show you once. So initially, let's say I want to insert 5. Right now, where will I insert 5? You both are empty. What are these? We will come on that. Wait, just let's try to understand. I have 5. I will, let's say, insert it in this pool of integers. Next up, I have 15. Where should I place 15? So one thing I want to make sure is that I'm not worried whether the integers are in sorted order or not. My intent is all the numbers that are less than x are here and numbers greater than x are here, right? So next up I have is 15. Where should I place 15? I will place 15 here. Okay, next up I have is, what I have is 1. So now how will you take decision? What is x here? X is nothing. X is the number that you are inserting. Now how are you going to take the decision that all the numbers are less here and all the numbers are greater here? So if I insert 1, okay, for example, if I insert 1 here, how are you taking this decision that where to insert the number that you are inserting? Now that's what you have to think about. So guys, at every instant you have to maintain these two streams in such a way that you get median in such a way. Let me show you, basically in less time complexity, how are we going to achieve that. So tell me, if there were only two numbers 5 and 15, what was going to be your median? Since the size of both the pools are same, it will be the average of both the two numbers, correct? Okay, but next up I have, what I have is 1, right? And ideally for 1, 5 and 15 the median is going to be 5. How am I going to achieve this thing? So see, now the idea is, that's where I'm going to crack what we are going to do. I am going to take two kinds of heaps here. This is going to be my max heap and this is going to be my min heap. Okay, let me go back to the question and show you what functions we want to complete here. Okay, so the functions that we want to complete here is, you see that I have insert heap, right? So the task of this function is that whatever integer from this stream I am choosing, I am inserting it into my heap, right? Which heap? We will discuss about it. Then balance heap task is that it is simply balancing the sizes of two, balancing the numbers that we are inserting in the two heaps, that in such a way that left heap should have all the numbers less than all the numbers that are in the right heap. That's what it is trying to make sure. Okay, if not, then it is making some necessary operations. Then the last thing is get median, whose task is simply to just check and give you the median, and rest of the work is actually being done by these two functions. Now how? Let's understand this thing. So guys, the intent here is that I am going to take my max heap, and you can choose it anyway. So idea is, whenever I have odd numbers, right, odd, the count of the stream is odd, right? For example, I have 3 different numbers or 5 different numbers. So what I'm trying to do, you can do it otherwise also, you can make that for min heap also. The idea is, whenever I have odd numbers, the extra number should be present in my max heap. Basically my max heap size can be greater than my min heap size. It can never be it should never be less. Why? Because when I'm asking find median function to return me the median, it should just go and check what is present at the top of the max heap. Now I am assuming that you already know what max heap is. So max heap will always have the largest number present in its heap at the top of the heap, and vice versa for min heap, that it will have the minimum number at the top of the heap. Now let's try inserting, then you will understand what we are trying to do. So initially, since I told you that we are going to make sure that either max heap size is equal to min heap in terms when we have even count of numbers, if otherwise max heap should always have one number, can have one number extra than the min heap but not less than that. Okay, so when max heap size is 0, right now both are empty. Okay, so if both are empty, I will insert my number. I'll start from max heap. So let's insert 5 in here. Okay, I inserted 5. Now next what I have is next stream. So right now, for example, at this point of time, I call my find median function. Okay, find median function will go and check what is present at the top of your max heap, right? If the max heap size is greater than your min heap size, in that case you directly return this answer, which is actually the answer. And had it been equal size, then we will return the top value of max heap and the top value of min heap divided by 2. Why so? You'll see. Wait. Now next number that I want to insert is 15. So max heap is already, when you see the size of max heap is greater than min heap already. If you insert again into max heap, that will be overflow in terms of it should be one size greater than min heap, not more than that. So to balance the size, I will insert 15 here. Now I will make call to my balance function, and the task of balance function would be based on what values I have inserted. It will modify your min heap and max heap in such a way that min heap, max heap, always, this left heap is always having the values less than the values that are present in your right heap. That's what balance function is making sure. Okay, so when I inserted 15, my balance function will go ahead and check what is the min heap dot peak value, right? So peak value will be the smallest number of all the integers presented, that is 15, and it will give me the max of all the integers present in the left heap, so that is 5, right? I will compare. If the maximum of this heap is less than the minimum of this right heap, that means we are in a good state, right? That's what we wanted. I wanted, imagine it in this way, that you have some pool which only has numbers, no matter how many integers, but they are always going to be less than that, and you simply pick the maximum of all those numbers. So if this minimum of all these numbers exceeds the max of this pool, right, then that means all the numbers are going to be less than all the numbers that are present here, right? This is one observation. Now I have inserted 5, I have inserted 15. Now if I make call to find median, what it will do? It will compare both the sizes. When it sees that both are of same size, it will simply return me the average of two numbers. That is the top peak value of this heap, peak value of this heap, and it will do its average and it will return 10 in that case, correct? Okay. Next up, let's insert 1. So when I insert 1, I see both the sizes are equal. When we are in that state, I am always blindly going to insert into my left heap. So I insert 1 here, and then I will make call to balance function that you go ahead and check if the values that I have in my left heap are always less than all the values that are present in my right heap. So that will be the balance function's task to do. That's what we are doing. So what it will do, it will check the peak value of left heap. So peak value of left heap will be 5. Why? Because your left heap is your max heap, and it will check the peak value of your right heap, which is 15. So if when I see that the peak of right is greater than the peak of left, that means we are in a safe position. That means all the numbers in the right heap are always going to be greater than this left heap, so we are in a good state. And for example, if I make call to find median at this position, so it will check that left heap size is already greater than your right heap size. So already I have the number that is at the peak of this heap as my answer, that is my median. And if you check also 1, 5 and 15, out of these your 5 is going to be the median. So that's how we are generating the answers, correct? So next up I have now last number 3. Where will I insert 3? So I saw that already your left heap is greater than right heap size, so let's insert 3 in here. Now I will make call to balance function to check if left heap's numbers are less than the right heap's numbers. So what it will do, it will check the peak value of your left heap, which is going to be 5, and the peak value of right heap, which is going to be 3. Why 3? Because your right heap is a min heap. The peak value will have the minimum of all the numbers that are present in your right heap. So when I check your min heap, max heap's peak value 5, and here it is 3, I can see that this 5 itself is greater than 3. That means something is wrong. I should swap these values, because my right heap is always supposed to have greater numbers and left heap is supposed to have the left half of the stream, that is the smaller numbers. So if the max heaps, that means the max value itself is coming out to be greater than the minimum of all these numbers, that means I should swap them. So once I swap it, okay, that's how your balance function is working. My 3 will come here, my 5 will go here. Now you see we are done with the correct kind of balancing, that is left heap always has numbers that are going to be less than the values that are present in my right heap. We are simply segregating the left half and the right half of a sorted array, right? Now when I call my find median function, it will go ahead and check what is the peak value of your left heap. So left heap's peak value would be 3. Why? Because it's a max heap. And it will check the min heap's peak value, which is going to be the minimum value here. You have 5 and 15, so it will return you 5. So 3 plus 5 divided by 2, that is going to be 4, is going to be your answer, right? That's how we are doing this question, and we have actually discussed whatever we are doing here. I'll just show you what we have done. Talking about the time complexity. So if you have studied about heaps, which is a prerequisite priority queue basically, you will know that all the time complexity will go in inserting into heap and calling from heap, right? Because it's a tree like structure, if you remember. So it takes almost the size of that tree's time complexity is almost equal to the size of that tree that is generating in a heap. So n log n will be your max time complexity with this approach. Okay, so here this left heap is the max heap that we are generating, and right heap is your by default when you write this statement in Java, it's a min heap. And when you want it to convert it to a max heap, you can use collections.reverse order, you can use lambda function, you can use comparator, whatsoever, your choice. Okay, fine. This is the straightforward one, until unless you are making a new class and you want to compare on the basis of some values that you are inserting. This is good to go. Okay, now in insert heap we are doing nothing, we are just checking if left is your max heap, right? I am making sure that my max heap size is always greater than my left heap size, or it can be equal but it cannot be less. So that's what I'm doing. I'm inserting left dot add x. I'm not going to iterate through every line, just showing you. If left dot size becomes greater than my right dot size, that means my max heap right now has a size greater than my right one. So what I'm going to do, I want to balance it. I'll add it to my right and then make a call to balance heap, whose task will be to check if I have the right values in the left and right. So on the basis of the peak values, it is swapping. If the max heaps, that is your left heaps, right, peak value, and the right heaps peak value, if that exceeds what the left peak is greater than your right peak, right, that means there is the left half should be less than the right half, so you will swap it. That's what we are simply doing it here. In left you will add the right's dot peak value, and in right you add the left dot peak value. And get median is doing nothing. The major tasks are being done by your insert and balance heap. It is simply, in case of even size, it returns the average. It returns the average, otherwise it returns what I have at the top of my max heap, that is my left dot peak value, right? And yeah, that's all about it. In case you have any doubts, you can ask me. Otherwise, we are done with this question. Okay, yep, so that's all about today, everyone. Let's wrap it up and see you all in the next lecture. Bye bye and take care.